All right, let's get into it. Today, we're putting on our geologist hats and taking a hard look at the moon. Why? Because there's this incredible theory out there that our closest neighbor in space isn't what it seems at all.
So this is the big one. This is the central claim we're investigating. The idea isn't just that the moon is hollow, but that it's an artificial structure, a kind of ancient alien satellite watching over us. It's a huge, mind-bending idea, and it's exactly what we're going to dig into.
And that's our whole mission here. We're going to act like detectives. We'll take each piece of evidence that's presented for this theory, one by one, and see if it stands up to what we actually know about geology and physics.
Okay, first clue. This one comes straight out of the Apollo program, and honestly, it's one of the strangest and most compelling bits of evidence that has kept this theory alive for decades. It's the story of how the moon, well, how it rang like a bell.
Here's how it went down. During the Apollo 12 mission, the crew sent their lunar module crashing back down onto the moon's surface. Now, they left behind these super sensitive seismometers, and those instruments picked up the vibrations. But the weird thing was, the vibrations just kept going for over an hour. And that's where the phrase ringing like a bell came from. I mean, a hollow object would totally do that, right? Well, maybe. Let's look a little closer.
So this is where geology really comes into play. Think about it. A bell is made of a single dense material, so vibrations travel through it super efficiently. But the moon, it's the complete opposite. It's bone dry and covered in miles of shattered, broken rock and dust we call regoliths. So when a seismic wave hits that stuff, it doesn't get absorbed like it would on Earth. Instead, it just bounces and scatters and bounces some more, echoing around inside that fractured surface for a long, long time. So it wasn't ringing because it was hollow, it was reverberating because it's basically a giant ball of shattered rock.
Okay, so the ringing has a pretty solid geological explanation. Listening to the moon is one thing, but what happens if we put it on a scale? If it's a giant hollow spaceship, it should be incredibly lightweight for its size, right? That's something we can actually check. So let's run the numbers. And this number right here is our next big clue. 3.34 grams per cubic centimeter. That's the moon's average density. Now, by itself, that number might not seem like much. But to a geologist, a number like this tells a whole story. You know, density is basically our superpower for understanding what's inside a planet or a moon. It's all about how much stuff is packed into a certain amount of space. It's really simple, right? Like, if you pick up two boxes that are the same size, you can tell instantly which one's full of pillows and which one's full of bricks. That's density.
And here's the verdict from that number. 3.34 is a perfect match for a solid body made of rock. In fact, it's pretty similar to the density of Earth's own crust, and it matches up with the rock samples the Apollo missions brought back. Our models show a crust, a mantle, and a small, dense core. For the moon to be hollow, its density would have to be way, way lower. The math just doesn't add up. All right, we've looked at sound, we've looked at weight, now let's move our investigation from physics to pictures. This is another huge part of the hollow moon theory, the idea that you can actually see artificial structures on the surface, evidence of the builders. So the claim is that if you zoom in on high-res photos of the moon, you start to see things that just don't look natural, things like towers or even glass domes, and some sources even connect these shapes to things people claim to have seen on Mars. This is where we have to be really careful detectives. See, our brains are wired to see patterns in things. It's called pareidolia. It's the reason you see a face in the clouds or a man on the moon in the first place. But a geologist is trained to look past that. So let's put on that geologist hat and see what's really going on. And this chart breaks it down beautifully. You see a tall, skinny tower. A lot of the time, that's just a mountain peak or the edge of a crater, and the sun is at a super low angle, casting this incredibly long, sharp shadow that looks like a spire. Those straight lines and geometric shapes, that's what happens when craters overlap, or when you have natural fault lines in the rock. And those glass domes? Well, meteorite impacts can literally melt rock into glass, which is super reflective. It all comes down to a trick of light and shadow in a place that's totally alien to us. So, after all that, where does our investigation stand? We've looked at the seismic readings, the density data, and the photographic evidence. Let's just quickly recap the method we used, because honestly, it's a toolkit you can use to analyze any extraordinary claim. This is it, right here. It's a simple, 4-step process. First, you just look at the claim. The moon rang like a bell. Then, you check the data. What do the seismometers say? Step 3, you think of other ways to explain it. Could it be reverberation instead of hollowness? And finally,
You just follow where the best, most consistent evidence takes you. It's a really powerful way to cut through the noise.
And when we apply this toolkit to the hollow moon theory, the conclusion is pretty clear. The ringing, the density, the so-called structures, they're all explained so much better by natural geology. The moon isn't a spaceship. It's a world, a really weird and wonderful one.
And you know, this is the coolest part. Saying the moon isn't hollow doesn't make it boring. It actually opens the door to the real mysteries, which are, in my opinion, way more fascinating. Like, why is the far side of the moon so completely different from the side we see? What's up with the strange pockets of magnetism in the crust? And what is hiding in the ice inside those craters that are in permanent shadow? We may have closed the case on this one theory, but it leaves us with an entire universe of new questions. The real investigation is just getting started.